Okay, we're going to start this video with a review. And one of the things that you guys already know about is this triangle. We put solids, liquids, and gases on it. And it doesn't really matter which corner we use. This is just my habit. And one thing that we talked about was adding energy. So if we take a solid and add energy to it, we can get a liquid, or we can get a gas. And if we take a liquid and add energy to it, we can get a gas. So if you add energy, you wind up over here at gas. I guess that's kind of the top of our drawing here. Likewise, instead of adding energy, you can remove energy. So if we start with gas and you remove energy, you can get a liquid or a solid. And if you take a liquid and remove energy, you can get a solid. So all of these blue arrows are removing or releasing energy, and all of these red arrows are adding energy. Okay? Now, we did have a bunch of words for these. Some of them were pretty simple, like from solid to liquid. We know that that's, we know that that is melting. So, melting. From liquid to gas, that's either evaporating or boiling. And since we're not talking about temperatures that high, we're just going to talk about evaporating. And then if you go from a solid directly to a gas, that was called sublimation. And if you go from a gas to a solid, that was called deposition. And if you go from a gas to a liquid, we call that condensation. And if you go from a liquid to a solid, we call that freezing. Okay? So that is part of our review. Now also, I want to review this pressure temperature diagram. It's called a phase diagram. It tells us what state of matter water is in. So just as a quick example, if you have a spot right here, well, that is a pressure of a little bit below 1 atmosphere and a temperature somewhere below 0. So that means what you would have is you would have ice. Okay? So that's how this pressure temperature diagram works. If you pick some other spot, like maybe here, that is at a temperature somewhere between 0 and 100, and the pressure is somewhere above 1 atmosphere. If you had that right here, then you would have liquid water. And that's how this diagram works. It's pretty simple. What's important to us here, one thing that I want you to notice is that as the pressure goes up, what happens? Well, what I really care about here is that you notice as the pressure goes up, what happens to how likely you are to have water vapor. The higher the pressure is, look at all this, it's all solid and liquid. So as the pressure gets higher, your chances of getting water vapor are less. Oh look, it's like a sad face. Likewise, if you take the pressure down, if you have less pressure, then look at what happens to the amount of solid and liquid. As you take the pressure down, you get more and more likely to get gaseous water. Okay? And what happens if we mess with the temperature? Well, if we take the temperature up, what happens to our chance of getting water vapor? Well, at a higher and higher temperature, this area gets bigger and bigger. So that means the higher the temperature, the more your chance of getting the gaseous state. Likewise, if you take the temperature down, you become much less likely to get the gaseous state, and you get more and more likely to get ice or solid water. So we just got a bunch of facts. It was a bunch of review stuff that you had seen before, and you have also seen this before. You've seen a graph of how the temperature changes with the altitude, or how high up you go. So what's important on this graph? Well, I'm going to tell you that for weather, it's only important inside this area right here. Why doesn't this matter up here? Well, there's not enough air to have weather, really. So if there's not enough air to have weather, we don't really care about this that much right now. So now that I've gotten rid of a lot of this graphic, what does matter to us? Well, where do we live? We live right down here on the ground. So let's draw a little person down here. This person is miles tall. I'm really tall. Anyway, so down here on the ground, what are the temperatures like? Well, the temperatures can be really high. And if you were to climb up a mountain or, skydive or something from really high up, what happens as you go high up? What happens to the temperature? The temperature gets colder. So look at how cold these temperatures are out here. So what you really need to remember is wherever there's weather, which is down here at the bottom, as you go up in altitude, you go down in temperature. Okay? So now I'm getting into what I wanted to get into, this image. And you've seen images like this before. What I think I want to do is I think I want to take as many of these things as I can, and I want to see where they fit on that drawing. So there's 6 words here, and I want to see in how many places I can put those 6 words and explain why. Okay, so I think I will start with melting. Ooh, probably not the best color choice there. But melting. So where could melting go on here? Well, what is melting? Melting is where you go from a solid to a liquid. So as far as water is concerned, I can see a couple places on this map where you could have melting happening. You could have melting happening here, because you've got snow and ice or whatever. And you could have melting happening here, because we've got this iceberg out here. So I'm going to have melting and melting. And I'd like to have an arrow for each of these. So if this snow is going to melt, what's it going to do? It's going to turn into a liquid, and that's where our river comes from right here. Out here in the ocean, when the iceberg melts, it's just going to become liquid water. So there I've added the word melting. So what's next? Let's go and do evaporating. Okay, so evaporating down here. Evaporating is going from a liquid to a gas. So this one might surprise you. This might be in more places than you think. Right here, from the ocean up into the air, you could have evaporating. I'm just going to write evap because I'm feeling kind of lazy. You could have evaporation happening from this river or lake or whatever this is. And is that it? No, because there's other liquid water in the picture. These raindrops can evaporate. Did you know that? Did you know that rain doesn't always make it to the ground? Just a second, let me go Google something. I'll be right back. Okay, take a look at some of these pictures. You've seen some of this stuff before, I would betcha. You're out driving around, and off in the distance you see these clouds, and it looks like there's curtains hanging down from the clouds. That's rain, but is it making it to the ground? No, rain doesn't always make it to the ground. If it falls into drier air or hot enough air that evaporates the moisture, then it doesn't make it to the ground. It's called virga, V-I-R-G-A. Be careful when you Google that one, by the way. So anyway, evaporation happens wherever there's liquid water that can become gaseous water or water vapor. So, it can happen from these streams right here. You could have evaporation. We already labeled it happening on this lake or whatever this is, or just really wide river. So what have we got so far? We've gotten melting and evaporation. So I've done 2 of the adding energy. So let's do the subliming one, this sublimate one. Sublimation is going from a solid directly to a gas. So where can that happen in our picture? That can happen wherever there is solid water. So that's one place is right here. So some of these water particles from this ice and snow here can jump into the air, and that's called sublimation. I'm just going to write sublimate. Am I done? Do you see 1 or 2 more places where I could write sublimate? If you're looking up here, then you're on the ball. Oh, let's see here. Yes, these snowflakes, as the snowflakes fall, some of their water particles could jump out into the air and sublimate. And what about the clouds? Are these clouds made of water, or are they made of liquid water, or are they made of little ice particles? Well, chances are really high that they are actually made of ice particles, especially if they're high up clouds. So, like up here, these cloud particles, they could become a gas, so they could sublimate. Alright, so I think I've covered all of my adding energy arrows. Now let's do these 3 in the middle here. Freezing. Okay, freezing. That should be an easy one, right? So where does freezing happen? Well, we could say that freezing happens down here at our iceberg. And freezing is going from a liquid to a solid, so I'm going to add an arrow there, and I'm going to write freezing. Or I'm just going to write freeze. Where else can a liquid become a solid, or at least in this picture? I don't know if I see any place else where that's actually happening in this picture. I suppose you could make the argument that it might be happening in that neighborhood, but I don't think I'm going to make that argument. I think I'm just going to say freezing. The only place that's happening is right here. Okay. So what else have I got to do? I've got freezing. I should check some of these off. Give me a second. Okay, that clears things up. All I've got to do is condense and deposit. So condensation and deposition. So condensation, where does that happen? Condensation happens where you go from a gas to a liquid. So where is a gas becoming a liquid? Well, it could be happening right here in this cloud. So this could be condensation. I'm just going to write condense. And so that would just be little invisible water vapor particles hooking together as they lose energy and become clouds. And when the rain actually falls, that's also condensation. Maybe I shouldn't have drawn that arrow right there. So condensation happens when these little tiny baby droplets hook together to make bigger droplets. They condense and get bigger. So I'm just going to write condense right here by the rain. Okay. Now, let's see. What else? Is that happening anywhere else? Where else is... I guess there's rain happening here, but I've already labeled it there, so I'm good. Last word is, let's see here, deposit or deposition. What is deposition? That is where you're going from a gas, remember gaseous water is invisible, water vapor is invisible, to a solid, something you can see. So I'm going to come up to this cloud right up here in this top corner, since that cloud has some snow on it, or coming from it. So sublimation happens when invisible water particles in the air jump on and make a solid, and they make the snowflakes get bigger. So I'm going to say right here, I'm going to say deposit. If you want to sound all sciencey, you can write deposition. So like I think I mentioned earlier, chances are really high that if these clouds are high up in the air, that they're all made of mostly ice anyway. But like I said, I'm focusing on this top right guy right here. So am I done or not? Is there another place where deposition could be happening in this picture? Well, like we said, deposition is where you're going from a gas to a solid. So deposition could also be happening here, where there's all this ice and snow here. So I'm going to write deposit right there. Could it be happening anywhere else in this picture? In this picture, well, I guess right here, it looks like the ground is kind of frosty. Maybe that's frost. I'm going to write deposit right here. So if I wrote deposit right there, that means that water vapor could be coming down and making frost. But if I added that, I should probably also add another sublimate arrow. Because if water particles are jumping down into the solid form, some of them are probably also jumping off into the gaseous form. So now that I've covered, I think, all the words in my triangle, there were some other words that are coming to mind from things that we've read lately, like all these trees and all this grass and these farm fields and stuff. They are all doing what? They're actually all putting water in the air too. It looks like it's closely related to evaporation and maybe sublimation or whatever, but the proper word for this, when plants give off water vapor into the air, it's called transpiration. I'm just going to write transpire, because these plants are transpiring. So transpiration happens when plants give off water into the air. And let's see, what else should I add to this? I guess whoever drew this picture, they spent a lot of time and put all these water particles in the ground to represent, you know, like a runoff and percolation and groundwater and all that stuff. But I don't know if that's the focus of this video. So I think I'm going to stop right here before I hit 15 minutes. And if there's anything I missed, we can discuss it in class.